how can I create a linear model for a relationship between two variables? Um, so that's what we're gonna do. I have some data here. We're gonna do that. It's just, yeah. So here's this data of hours spent studying in the grade on an exam. Let's call it a math test, right? We're gonna plot this data, create a scatter plot. So hours at 3, we go up to 85. Here's 85, here's 3, so about there. 2 is 77, so this is 75, a little bit above that. 2 hours. Again, it's not going to be perfect, and that's okay. For the point of a scatter plot, we don't need perfection, we just need close. 170, 0, 60. So that's going to actually be very helpful in creating a model. Since we constantly have a 0 and a 60, like this is going to be a linear, when we create a linear model, we already have a y-intercept, assuming this has a linear relationship. 4, 92, so here's 90, hold on, 5 was a 90, so the 5, 90, let's put that there, and 4, 92, yeah, that'll be good enough. 375, 375. So if I were to like try and draw a line here, you might want to get a straight edge or something. I might draw something like this, maybe go through this 60, since it's already there, and kind of like here, right? And for this, we want to try to see if we can come up with maybe a slope. So I'd say maybe it goes through this point here. So maybe this is like a little above 70. So this is 76. This is 3 comma 76. So from here it was at 0, 60. Right? So it goes up 16 over 3. So the slope would be up 16. So rise of 16 over 3. It's a positive correlation. We're going to, if we have a positive association, we end up with a positive slope. So this is the slope of this line that we draw. Again, you try your best to go through maybe a couple points here. You want to hit the y-axis. So then what we can do is we can write an equation now, a linear model. And this linear model that we're going to create can be used to make predictions about the situation. So I can say, okay, I want this grade, so how many hours do I have to study? And you can work your way backwards from there. So I have 16/3 as a slope. My y-intercept is going to be 60. So if I don't study at all, apparently I will get a 60 based on this interpretation. So we do y equals mx plus b. So y equals 16/3 times x plus 60. Now I have this. What this says is that for every hour studied, my grade's going to go up 16/3, or what? 16 divided by 3 is roughly 5.33, repeating, 5 1/3. So for every hour I spend studying, my grade will go up 5.33 points. And if I don't study at all, I'll get a 60. That's what this says. And then we can use it to make a prediction. Say I want to know if I study for 6 hours, what grade might I have? Well, that's not shown on the graph. I could just go to the graph and go up and say, oh, it would be about this, right? So you might say, okay, so for every hour I get 5 points. 5 times 6 is 30. And then 5/3. And then that plus 60. So it'd be like a 90. You'd have over a 90 if you studied for 6 hours, probably a 95 or so, like that. So just keep that in mind. This is just a linear model. So that's what this linear model is here. This line and the equation is the linear model you can create simply by drawing a best fit line that kind of fits through most of the points. And then it can help us predict and tell us more about that relationship.